Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to another week of NL Math Man Math Help streams, another week of offsite distance teaching, right? This is week six of distance classes. Boy, starting in on the 25th stream. Oh, we're getting up there. Hey, we're settling into this temporary normal, I suppose. I'm gonna say new normal, but it's not it's not completely new right now, although we did still sort of, have to rush headlong into it. It's not like we were the most prepared in the world. But hey, I think we're getting through. We're doing pretty well. Just Friday now, this past Friday, of course, we had submitted courses for the month to get them complete. It was a great month. Gotta say, everybody who's been working at the campus that I teach at, doing really well. Super pleased with the buy-in that we've had for our distance system. Even though it was kind of rolled out really quickly, right? Based on some sort of vague ideas about what we might do that I had sort of bouncing around from before and all this kind of stuff. We just kind of rolled it out and got put it together piece by piece, and super pleased that it seems to be working, that people are buying in, getting work done, able to carry on their education. So, you know, congratulations to all the students who completed courses and completed tests and activities and assignments, and yeah, it's great to see the buy-in being as high as it is. Right? And today, of course, today is May the 4th, right? That's right. Yeah. This is Star Wars Day, I guess, May the 4th. So I decided to stick a little bit of a reference there in my in my stream title for today. Vacationing on Hoth with the Wampas. Hoth is probably a great place to go for social distancing, I imagine, because there's not a whole lot of people there, right? Like as we found out when Luke, crashed his snowspeeder and then had to slice open the was it no, it wasn't the Wampa that he sliced up, or was it? Was it no, the Wampa ate the crap. What was that thing that Luke was riding? That like ostrich looking thing in Empire. Someone's got to know that ostrich looking thing in Empire. I could Google that. It would probably come right up, right? Oh, what's this? Is this okay? It's all right. I was just a work related message there. I have to get back to that there now in a bit. Yeah. So the Wampas, I imagine, Wampas don't count, I guess, for social distancing because they're like, gigantic polar bear humanoid murder machines. So you can probably, right? Like, can they get COVID? I don't think so. Right? They're not a vector for transmission. So you should be fine, is what I'm saying, if you vacation on Hoth. Although getting there might be hard because, it's a long, long time ago in a galaxy far, far away. But anyway, I've got these little, there we go, this little guy. You scratch him under the chin. There we go. That guy. And Smokey and Flurry again, as usual. But over here now you can see them out in a wonderful snowscape. It actually snowed. It actually snowed yesterday in Gander, where those doggies live. Yeah, it's back to being winter in central Newfoundland apparently. But little girl over there, Flurry, she loves winter. Oh yeah, always out rolling around in snow. She loves it. Nothing better. Nothing better. You see her walking sometimes, and she'll just like face plant, just be walking along, trot, 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 then poof, just sort of face plant directly into snow, and then roll around a bit, I guess to cool off or whatever. But poor little Smokey, look what happens to him. Let me switch my background. See this? See down in the corner there? He gets all those little like balls of snow stick to his fur. I don't they don't hurt obviously, but it can't be super comfortable to him. Maybe having all that much hanging off his mane, I guess, right? But so you got to put up with, I guess. When you're gallivanting around in the snow, some sacrifices you got to make. Anyway, I have been rambling now for a few minutes about basically nothing. So I am going to get into the math. Yes, because that's what I'm here for, right? So today the topics are going to include we've got Math 1101C exam review. We're going to do some straight line graphs. Um, that'll be Betty Ann is currently on to that, but it's a really good topic for a lot of different people, especially because, say, afterwards, when I go into Math 3102A, for Esther's Unit 3, that is basically exactly the same topic, right? Now, the academic program covers it in Math 1101C, and the general covers it in, like I said, in 3102A, but it's like literally exactly the same topic. So it'll be super useful for Esther and Betty Ann to see both those sections, really. After that, I'm going to do a little bit on properties of angles. Nick is onto that one there now. I don't know if he's watching live, although he has before. But yeah, as the normal procedure is, I'll link it afterwards. So even if you're not watching it now, and if you're not, then there's no way you're hearing me. So what's the point of me saying it, right? Anyway, we're going to go back over to this picture. This is twice as adorable, right? This one is only Smokey's great and all, but this is two doggies. Two doggies is more adorable than one doggie, obviously. But anyway, we're going to switch over to zero doggies, and we're going to switch over to some math work right now. So let me see. We can't see that quite as well on this screen, so I'll bounce over here. There we go. So write an equation. This is going to be page, the heck page is this? Let me scroll down. 390. All right, so this is for Betty Ann's current course, and this is page 390. So let me just start writing that down. This is Math 1101C, exam review. I'm going to focus my review mostly on the first unit because that is page 61. It was page 61 of my PDF, but it's page 390. Okay, never mind. I even just looked at that, didn't I? And I'd forgotten that quickly. Page 390. It was page 61 of my PDF, though, so in my defense. All right, I am going to focus mostly on Unit 1 for the review today because Betty Ann just did her Unit 2 test, so that's probably fresher in her mind. Oh, hello, Esther. Yes, great. Thanks for dropping by. Now I'm going to do some stuff for Betty Ann first, and then stuff for the current course that you're on. But it's the same topic. It's just handled a little bit differently. So if you want to hang out and watch these as well, that can be beneficial to you as well. Okay. So our first question here, 19A, tells us write an equation for a line that passes through each pair of points and describe your strategy. Now, I don't spend a ton of time talking about the various different forms of a line, right? But there are some other forms of lines that are quite useful to us, right? And one form of a line that we can have is what we call the slope point form. Now, slope point form is distinct from slope intercept form. Slope intercept form is the one that I normally use, and I like that one quite a lot. Slope point form is really useful as well, though. Slope point form is y minus y1 equals mx minus x1. And what does this mean? Well, this is our y and our x, like our variables. But this is oh no. My blue pen, my beautiful blue pen is running out. Oh no. Boy, I'm gonna have to brave a trip to Dollarama, see if I can get some pens. And this is the x chord of a point on the line. Right? So it's y minus y1 equals m x minus x1. Oh, and m is still the slope, as always. Right? So we can use this form of the line with one of the points that were given over there in question 19. Right? Actually, let me zip back over to this display so we can see it a little bit bigger. So the points that we have are, let's see, we have point G is -3, -7. We're given that one. And we have point H, which is going to be 1, 5. Okay? Now I can pick either of these sort of to do either role. But what I'm going to do is I'm going to put those in here as y1 and x1, right? So what I can say is that this line can be y minus, it's going to be a y minus minus 7 if I do this, which is going to be a y plus 7. It's going to equal m, because we don't know that guy yet, right? It's going to equal m outside of x plus 3. Okay? So this now I've taken that and substituted it in here. Okay, so I'm going to say using 1 point, we can get a slope point form without m. And I say to get m, so to get m, now we're going to substitute the other point into the formula, right? So we used point g, -3, -7, in order to generate this, right? But now what we've got is we've got one equation with 3 unknowns. We don't know what y is, we don't know what x is, we don't know what m is. We can't solve one equation with 3 unknowns. We can solve one equation with 1 unknown, or 2 equations with 2 unknowns, or 3 equations with 3 unknowns, so on. Oh, and so on and so on. But here now, what I can do is I can take this 1, 5, and I can put it in for the y and the x over here, right? So what I can now say is, sorry, it's not a 1 because that's the x coordinate. 5 plus 7, pretend I drew that 5 a bit more accurately. 5 plus 7 is going to equal m outside of 1 plus 3. Now indeed we can solve for m, right? Because over here now we're going to have 12. 12 equals 4m. I divide and I get 3 equals m. Okay, by substituting it in. So now I know that the formula has got to be y plus 7 equals 3 outside of x plus 3, right? And that is one of the ways that we can do this one. I could have also used this same one over here, right? And it would have worked out to be the same thing. So to show you a little bit about this and how these work, let's bounce over to the Chrome window, to Desmos, for just a second, and I'm going to type this in, and we're going to see what it actually ends up looking like. Right? So what we've got here now is y plus 7 equals 3 outside of x plus 3. There we go. Right? And now if I did this correctly, this should be a line that has both -3, -7 on the line, and it should have 1, 5 on the line. Well, let's find out. Let's find out if it has those. So -3, -7 would be, oh, we are seeing my cursor, good. -3, -7, is that this point? -3, -7? Hey, look at that. There it is. -3, oh, I'd move my mouse a little bit. -3, -7, though, is indeed on the line. We can see it right there. There we go. Ah, did it again. It's tough. My mouse sensitivity is too high. I'm like a CSGO scrub, right? High mouse sensitivity. What am I doing? And then up here, 1, 5. 1, 5 is also on the line. Hey, sorted. Right? It's right there. There it is. Yep, we got it. And now, say, imagine I was to, imagine now I was to put in the other point instead, right? Imagine back over on this one, right? Imagine if instead I substituted this one in here, and instead had y, let's see, y minus 5 equals, because the slope should be the same, right? Y minus 5 equals 3, x minus 1. Is that going to work? Is that going to get us the same? Well, let's find out. Let's find out. I'm going to graph it over here, add a new expression, graph that. So it's going to be y minus 5. Don't mind me reaching out across and zooming in. Y minus 5 equals 3 outside of x minus 1. Close up. Hey, look at that. Oh, that's the wrong video capture device to lose. There we go. See? This black line, exactly the same as the other line that was there below it. Right? You can see it's just overlaid right on top of it. Right? Because those two equations, even though they look different, they do represent exactly the same line. Okay? So when you were doing or if you were doing a question like this, you will see that there are two possible results, but either one of those is totally fine, right? So let me do 19b as well then, or part two rather, I should say. So this is a part one. So let's do a part two. So part two, we've got points j, which is -3, 3, and we've got k, which is 5, -1. Now, another way that we could go about doing these is we could find the slope first. See, because what I did with slope point form was I found a point first, and then I used those points sort of to find the slope. Now, you needn't do it exactly that way. Okay, sorry, I was just configuring something there. So you needn't do it that way. Say we wanted to do a different method, right? We wanted to find the slope first. Well, we know that the slope is rise over run, right? Which is otherwise known as delta y over delta x. Hello, are you able to help with Calc 2? Um, Calc 2. You can give me an example of some questions, perhaps. I may be able to. Andrew Magner. Yeah, I'll take a look and see. The program that I teach here doesn't include Calc 2, all right, or whatever that would be because we go up to logarithms. But yeah, you can put some questions in chat, and I'll see about getting to those once I finish up with these few here. So we have delta y over delta x, y2 minus y1 over x2 minus x1, right? And now I'm always going to pick the leftmost point to be the point 1, right, of these two guys. So we know the leftmost point is going to be this one. So I'm going to call this 1 and this 2, you know. So the y, and I'm just going to keep on going across horizontally here. The y of point 2 is going to be -1. Subtract the y of the first one, which is 3, right? Then we're going to divide this by x2, which is 5, right? Minus x1, which is a -3, like so. Right? So we'll have then -4 over, that's going to be a +8, which is also a -1 over 2, right? So here now, I've just sort of gone across. But this now, I found slope, or m, right? M equals slope, blah, blah, blah. So if I was going to do y equals mx plus b, say for example, now we've almost got there, right? Because I have m, it's -1/2. Y equals -1 over 2x plus b, like so. Right? What I'm going to do now is I can take either of these 2 points and plug them in here for the y and the x, and then I can solve for b, or solve for our intercept. Right? So I can call this y, or sorry, I can call this +3 equals -1 over 2 times -3 plus b. Here, like so. All right? Because now I've taken this to be my x-coordinate, this to be my y-coordinate, and I've plugged those in over here. So I'm now going to have 3 equals 3 over 2 plus b, right? So I'm going to subtract the 3 over 2 from each side. 6 over 2 minus 3 over 2 equals b. 3 over 2 equals b. So I now know that the formula of my line here is going to be y equals -1 over 2x plus 3 over 2. And that now should be a line that incorporates both these points. All right, so let's go check and be 100% sure that that is what we have. So we switch on over to Chrome. There we are. I'll just deactivate those two so we're not seeing them. Add a new expression. Okay, y equals -1 over 2 x plus 3 over 2. There we go. So now, if I did that correctly, there should be negative 3, 3 should be on this line. Oh, look, there it is. Negative 3, 3 right there. Hey, got him. And I should have 5, negative 1. There it is. 5, negative 1. Checks out. Good stuff. Okay, we did it. Now, let's see. What else we got? Now, we switch on back over to here. What was part B? Use each equation you wrote in part A to determine the coordinates of another point on each line. Okay, easy enough. I'm going to go ahead and, excuse me, hiccuping. So for B then, I'll just cram this in down here in the corner, because B is going to be a fairly quick question. I'm just going to use the equation to find out any other point on the line. Well, for every y value, there is an x value, right? Because it's a function, these lines are. These are just straight lines. They don't have any non-permissible values. So I can just pick any value of y or any value of x that I don't already have, and then solve for that. Then solve for the other one, right? So like say if I took this guy here, say I did, oh, I don't know, I don't have the x point that corresponds with the y value of 2. So I'm just going to plug in a 2 for the y. So say 2 plus 7 equals 3x plus 3, like so, right? 9 equals 3x plus 3. So then 3 equals x plus 3, 0 equals x. So on that first line that I did, oh, I've gone too low, have I? There we go. Perfect. Okay, got a little too low. So now if I switch back over to my Chrome window, we can take a look and see if that point is actually on the line. Oh, document display, Chrome, here we go. So I found 2 or 0, 2. There it is, 0, 2, right there. Another point on the line. Okay. Now let's do one more to show the other one, because let's answer the full question. So then the one from part 2 over here, I'll do this one in green. So here I have the y coordinates of 3 and negative 1. I'll substitute an x coordinate, and this time I'll do 4. I'll do x equals 4. Why not? Right, so I'm going to have y equals negative 1 over 2 times 4 plus 3 over 2. Right? So then y is going to equal negative 2 plus 3 over 2. Y is going to equal negative a half. Okay? So there should be a point 4 and negative half on this line. Let's find out. Over to Chrome here. 4 is right there. There it is. 4, negative 0.5. Got him. Okay. That's good stuff. So I'll switch back over. So Betty Ann, if you're watching there, stop me at any point if you've got any questions, because this should be hopefully this is good review for the test that you're going to be doing shortly, well, tomorrow. All right, if you have any specific questions, please let me know. I'm going to carry on and do number 20 here. So 2 families went on a traditional Nuchenolf. I hope that's right. A Nuchenolf dugout canoe tour on Tofino Harbor, BC. One family paid $220 for 5 people. Other family paid $132 for 3 people. Choose variables. Excuse me. Then write an equation for the cost as a function of the number of people. Well, they've told us what variables to use, right? Because when a math course or a science course or whatever tells us to write something as a function of another thing, they've already told us what variables they want us to use, right? Because here we know that our variables are going to be cost and number of people. Okay, so, but I mean, fairly obviously from the question, it would have to be that, right? me keep knowing it's a Math 1101C review. Then, let's see. Choose variables, write an equation. So we have 220 for 5 people. So the cost of 5 with 5 people is 220. I'm going to write it down like this. And then the cost of 3 people is equal to 132. Okay, we can write it like this. This is a notation that you will have seen, I believe, in at a previous unit. You would see it written like this for the function notation. But what this means is, right, we have 2 points now, right? So we have 5, 220. That would be a point on this line. We also have 3, 132. That will be a point on this line, right? So now we can use this to determine the slope of our line. We can use, and then basically we're doing the same thing as we did in 19, the one above here, right? So there are a few different ways that we could do this. I'm again going to do the slope first, right? So it's going to be delta y over delta x, right? Now our y's are these two. So our second y is 220, and our first y is 132, right? Our second x, now we're always going across ways, right? So the point that will be further left would be this one, 3. The point that would be further right would be this one. So x2 is 5 and x1 is 3, right? Because you can think of it as it's going to the right 2, and then it's going up, what is this, 88? Yeah. 88 over 2, which is going to be 44. So now we know from doing this that the slope of our line is going to be 44, which means that's the charge for every individual person. Each extra person is going to charge $44, right? So now we can go ahead and solve and see what the basic charge is, or what the y-intercept would be, or indeed if there is one, right? So what we would have now is y is going to equal 44x plus b. We don't know what b is. B could be 0. B could be 100. We're not quite sure right now, right? But we will be sure in a second after we take one of these points and substitute it in. So I can say 220 equals 44 times 5 plus b. 220 equals 44 times 5 is half of 440, which is 220, plus b. 0 equals b. So we know that there was no base charge. Boy, it's a pretty good setup that these guys have. You don't no flat rate to get going. You just, $44 per person apparently. So we know that our cost is equal to 44 times p times the number of people. That's it. What is the cost per person? How can you determine this from the equation? Well, the cost per person So as we do see in calculus later on, right, the slope of a line, or the rate of change of a line, right, is also the derivative of the line function. But what that tells us is that for each person, each p, the cost goes up by 44, right? So if I was to graph this, it would be a super simple one to graph, because it's just going to be y equals 44x, right? Now I got to zoom out a touch here because I was zoomed in quite a bit. Yeah, I mean, you see that it increases relatively quickly. So I would really need a different scale here for my Desmos graph to look sensible. But all it is that y is equal to 44 times x, right? And then it's cost per person. A third family paid 264. How many people went on the tour? Well, that's not super hard, is it? C is going to be So it'd be 264 equals 44p. 264 divided by 44 equals p. 6 equals p. Right? Good. It's good stuff. Now, Betty Ann, I chose these ones to do specifically because I thought these gave a decent overview of some of the ways that these are going to be handled on a test in word problems. Let's do a little bit on the form, though. I would like to do questions 21 and 22 at least as well. So number 21, let's see, do I have, oh, I've got a new blue, hold on, hold the phone, whoa, wowzers. All right, I do have a new pen, but apparently the package for it was under my camera. Let me open this guy, see if this pen's any good. Brand new blue pen, there we go. Okay, how's it look over here? Am I good? Oh, yes, beauty. Ah, good, good. Ah, yes, excellent. Another portable hole in the fabric of space-time. Good stuff. Okay, so then this is number 21. Ooh, that's a weird. Oh, okay, that's a different size. It's a needle tip pen. Interesting. This is not a gel pen. Look at that. Look at that tip. Can you see that tip? Oh, it's vanishing. Never mind. There, see, look. Okay, so for question 21, why is it not in general form? Well, for part one's a little bit pedantic, right? Why is it not in general form? Well, general form is ax plus by plus c equals 0. So to put it in general form, you just got to rearrange it, right? So this one in general form would be negative 5x plus 4y minus 40 equals 0, right? Really small difference, but a difference nonetheless, right? To get it into general form, it should be the order of x's, then y's, then constant, right? For number 2, it's a touch odd for some of these. Like, why are numbers 2, 3, and 4 not in general form? Well, because they're in a different form, right? Like saying why they're not in a different form is like because that's how you wrote them? Question mark. Like it's a little bit of an odd question. But on your test, what's coming up, you may indeed be asked to say take one of these and to rearrange them and put them in general form. Now, another thing about general form indeed for number 2, it should have all the stuff on the same side, right? So you start off with 1 over 3 x plus y equals 4, but that 4 needs to come over because there needs to be a 0 on one of the sides in order for it to be general form. So we would have 1 over 3 x plus y minus 4 equals 0. That's part of it. But also another part is that general form shouldn't have a fraction. So I'm going to call this x plus 3y minus 12 equals 0. General form shouldn't have fractions. Right? So now, this part here, this one is now in general form. Right? So let me just keep on going there. I'll do a few more of these. So part 3, excuse me. Part 3 is y minus 2 equals a third x plus 4. Right? So this is the form that I just showed you earlier, which is slope point form, which is also a really useful form to have, right? Because from here, we could go ahead and graph this just by looking at it much more easily than we can, say, with these ones over. Well, with this one here, we could do it all right, but we got to take this coefficient and divide it by that, and then take the negative of it, right? Anyway, I'm getting a little bit sidetracked here. But say if you're given general form, like this one, you would know that for here, you would have negative 40 divided by negative 5, which is a positive 8. Then you would take the negative of it to be a negative 8. And we know that negative 8 is then going to be the y-intercept, right? Anyway, this one over here now, we can go ahead and put this into general form. What we would have to do is kind of multiply out everything, right? So I'm going to get rid of this 1 over 3 by calling this now 3y minus 6, and that's going to equal x plus 4, because I've multiplied both sides by 3 to get rid of this fraction. Now everything needs to be on the same side in order for it to be general form. So it's going to be a negative x plus a 3y minus a 10. It's going to equal 0. And that now is general form. Okay? Or what I could have done is I could have moved them all over to the other side, right? And I could have called it 0 equals x minus 3y plus 10. Either of those work out just fine, right? So in all these cases, you're going to have two different examples of general form. Generally, we do make it so that the leading coefficient is positive, right? Oh, okay, so over here, I guess what I should have said. What I should have said for general form here would be 5x minus 4y plus 40 equals 0, right? Generally, you do want the leading coefficient to be positive as well. And then for part 4, let's go ahead and do that one. Yeah, there should be enough room to do it over here. Part 4. That one is y is equal to 1 over 5x plus 3. So this one is in slope-intercept form, which, is my favorite. But, hey, lots of different forms work. So I'm going to multiply both sides by 5 to get rid of this fraction by the x. I'm going to call it 5y equals x plus 15. Then I'm going to move this y over, and that's going to be 0 equals x minus 5y plus 15. And that then is general form. Okay? Write each equation of part A in general form. Well, there we go. That's what I've done. Graph each equation. Describe the strategies you used. Okay. So you will have to do questions like this for graphing on your test, right? There's a whole bunch of different ways to graph these. And I am not super concerned with if you remember all the different rules for graphing all the different ones from the equation. Now, there are ways that you can graph any of these forms, general form, slope point form, and slope intercept form. You can draw graphs straight from those forms, right? And if I go over here to the calculator, we can see it a bit more clearly what I'm going to do, right? So let me just go ahead and add some expressions here. I'm going to go ahead and graph these two guys. Let's go over. Now we can see my previous ones are left there from before. I'm just going to leave that. But we've got 3x minus 4y minus 24 equals 0. I should have been looking. Hey, boy, oh boy, when I get close to my camera, it does not, the chroma key does not like me getting close to that camera. No, it does not. Boy. Okay. 3x minus 4y minus 24 equals 0. There we go. There's our line. Okay? So let's zoom in on this guy here and see what we notice. Right? So what's this point down here? 0, negative 6. Well, how did we get negative 6 from this? Well, we know that if we take 24, right? So this number here, this 24, is negative 24 rather. We take this negative 24 and divide it by the coefficient on the y, which is negative 4. We end up with a positive 6, right? And it's always the opposite. So the term in front of the y determines the y coordinate of the y-intercept, right? The term in front of the x and the constant, right? So these two determine the y-intercept. These two determine the x-intercept. So we know now that the point of the x-intercept should be this negative 24 divided by negative 3, divided by positive 3, sorry, which will give us negative 8, and then we always flip the sign afterwards. So negative 24 divided by positive 3 is negative 8. So we should see that the x-coordinate, there it is, positive 8. You see? So that is a way that we can go ahead and graph these straight from the equation without doing any sort of rearranging. Right? Because what we know then is we know that this is Math 1101C review. We do know that. And we also know that then for general form, right? So this is 22A. General form is AX plus BY plus C equals 0, right? And then we know that the x coordinate of the x-intercept is going to equal negative C divided by A, right? And the y-coordinate of the y-intercept is going to equal negative C divided by B, like so, right? So here now, the equation that we're given in A is 3 minus, or in 1 rather, A1, 3x minus 4y minus 24 equals 0. So then, negative C over A is going to equal a positive 24 divided by a 3, which is going to be an 8. So therefore, we know that the x-intercept is going to be 8 comma 0. Right? And we can do the same thing with the other point. So we have negative C over B, right? So then we can call that 24 over negative 4, which is going to be a negative 6. Therefore, the y-intercept is going to be a 0, negative 6. Right? And if we go back over to our graph, we can see that that indeed is correct, right? Like I was just saying, we've got our 0, negative 6 down here. We've got our 8, 0 up here. Excuse me. So that is one way that we can go ahead and just graph it straight from the equation. Now, I know that you might not have done this in this form or in this method, and that's totally fine. I'm not gonna, on your test, I'm never gonna say, hey, you have to know how to graph it directly from this form without rearranging anything. Say you wanted to rearrange to slope point form, like, or slope intercept form, like what I often do with these, right? Oh, okay. I am going to have to find the slope eventually. So actually, from this one now, we're not quite done, but we'll get back to that in a second. This is not B, actually. This is A2, right? So for A2, we've got x minus 3y plus 12 equals 0. And say, like I said, say I want to rearrange that into slope-intercept, right? That means I have to get the y's by itself. Everything else can stay. Y's need to move. X plus 12 equals 3y, because I've just moved these y's over. Now I divide both sides by 3, because y needs to be by itself. And I'll get 1 over 3 x plus 4 equals y. Okay? And that means now I know that the slope is 1 over 3, so it goes up 1 when it goes to the right 3. And I know that the y-coordinate of the y-intercept is 4. So when x is 0, y is 4. And let's see. X minus 3y plus 12 equals 0. Okay, so that was the original. Let's pop on back over then, over to my graphing window. And we'll see here now, well, what's this? 0, 4. Hey, look, it's true. And then if I go to the right 3, I should go up 1. So there should be 3, 5. There it is, right? Go to the right another 3, 1, 2, 3, up 1. There it is, 6, 6, right? So that indeed is the correct line then. And now, since we've already rearranged it, our part B is actually quite a bit easier, right? Because part B, oh, didn't need to see my email then. Part B actually asks us to find the slope of the line. Well, for B, you already got it, don't we? It's right there. Got him. Slope is 1 over 3, sorted. Right? That was easy because it's right there. But say for part A, the way we did part 1 over here, how are we going to do that in B? Well, we could go ahead and rearrange this the same as here, but I want to keep showing different methods of doing these because, there's loads of different methods of doing it. So I'm going to just use this, right? So slope, I'll write it out properly, but you'll see that there is a shortcut, right? Because this is a 0 and this is a 0. But anyway, slope is going to be rise over run, right? So that's delta y over delta x, which is y2, x2 minus x1, yada yada. So our furthest left point is this one here, right? So our y, so this is point 1, and this is going to be point 2. We're going to treat it like so, right? So the y coordinate of 2 is 0. The y coordinate of this one is a negative 6. The x coordinate of point 2 is 8, and of the original is 0, right? So we're now going to end up with a 6 over 8, right? Which is going to be a 3 over 4 slope. And does that make sense? Well, that would mean that it rises 3 when it goes to the right 4. So let's skip on back over and see if that pans out. So we can start here at 0, 6. Then we go to the right 4. 1, 2, 3, 4. Up 3. 1, 2, 3. Hey, look, there we are. We're right spot on the money. Hey, let's try it again. 1, 2, 3, 4. 1, 2, 3. Hey, there we are. Right? So, I mean, quite clearly, you can see that these numbers here, the 6 and the 8, are just the intercepts, right? Although it's not negative because we know that it's going up, because we know that the line kind of looks like that, right? That is how we can find those ones. Okay, so Betty Ann, I hope that was a good little primer there for those types of questions. Just a quick refresher on those. Again, please, if you're in chat or if you've got any specific questions that you want me to go over, please let me know. I do indeed, I still answer questions even when I'm not streaming, especially if it's just like something quick that I can fire off. The reason I prefer to do it on stream is just so people can see me working through it like I would do in class. But if you want to do your test tomorrow, and if you've got any questions later on after the stream is over, do email me, and I will get to them as soon as I can. So now flick back over to my intro screen. Stream starting soon. No, it's already started. We're going. So now I'm going to get on to Unit 3, Graphing Equations, Math 3102A. Okay, so Esther, this is the unit that you're on now, but it does carry on with some of the same topics that Betty Ann was working on. So let me see here. We're going to do, what numbers are we going to do? Math Work 12, page 140. Here we go. Document display. There we go. So this is page 140? Yes, indeed. 140, right there in the corner. So I'm going to do a few questions off this page. Math 3102A, Unit 3. So a common price for downloadable apps is 99 cents. Write an equation that can be used to determine the total cost of buying apps, I, if you know the number of downloads, D. Well, we don't really have enough information, but we'll play along here, right? Because it says a common price, but it doesn't say like the only price. But anyway, we'll assume that they gave us enough info, right? Don't have to be cheeky about all the questions, I guess. Equation that can be used to determine the total cost, I, if you know the number of downloads. Well, the total cost is always going to be the number of downloads, right? Or the number of units times by the cost, which in this case is going to be 0.99. So I'm going to write it in dollars. That's all, right? Like, it seems a bit too simple, maybe, but that's all that it's asking, really, right? All you've got to say for here is I is equal to 0.99D. That's it. because the total cost is going to be equal to 99 cents multiplied by the number of downloads. So use your equation to calculate the total cost for 0, 1, 2, and 3 downloads. Well, I'm going to use draw up a chart, like what I often recommend. Like so. There we go. So now, this will be D, the number of downloads, and this will be I, the total cost. I'm not sure why we're using I for the total cost, but whatever. So 0 downloads, I mean 0 cost. That's, come on. 1 download, 99 cents will be your cost. 2 downloads is going to be $1.98. 3 downloads is going to be $2.97. And so on. And so on. And so on. Right? Just to borrow some the Slavoj Žižek catchphrase. And so on, and so on. Okay. So, does the equation model a direct variation relationship? Yes. This is maybe a little bit of a long-winded way of phrasing it, but this is exactly kind of what I would want to hear, right? So when it asks you, is it direct variation or partial variation? Well, here you're going to say it's direct variation because when one variable is 0, the other is 0 as well. That's all there is to it. Right? Use your equation to determine the cost for 10,000 downloads. Whatever. This is a little bit silly, but I mean obviously the cost is going to be 0.99 times a download. So the cost is going to be 0.99 times 10,000, right? So I'm going to move this decimal place to the right 1, 2, 3, 4 times. So it's going to be 9,900. Not super complicated, is it? Right? And the next one, I equals, so for 2, 0.99 times, right, times a quarter of a million. Not a super difficult question. 0.99 times 250,000. I'm just going to go through and do all of it. Why not? Now, 1.45 million. That's a decent one, right? So I can call this. I can just write it out, right? Which is what I'm going to do here. 145,000,000, right? Or you could do 1.45 times 10 to the 6. Right? That's another way of abbreviating. I'll just put that there in a bubble. Because we don't really need to concern ourselves with the scientific notation right now. But 100.45 times 10 to the 6 is that, right? In a calculator, E means times 10 to the, but when you write it out, you'll have to do it like that. Times 0.99. 435,500 dollars. That's it, right? That's all you got to do for those. Let's see. Oh, hold on. Let me mute. Okay, I'm going to go ahead and do question 7 here. Then I'll do some stuff for the unit that Nick is on really briefly. And then, yeah, that'll be my time for the day, I think. So the cost to a customer at a bulk food store depends on how much the customer buys and the unit cost of the item purchased. Well, yeah, of course it does. One type of almond snack sells for $2.67 per 100 grams. Express the cost of the almond snack per kilogram. Okay. Well, if it's 2.67 per 100, that's going to be some number over 1,000, right? Because you want it per kilogram. This is one way to do it out, and this is one way that I've shown quite a few times, right? Another way to do it could be just 2.67 over 100, right? We're going to times the bottom by 10. If we're timesing the bottom of a fraction by 10, what have we got to do? Well, we got to times the top by 10 too, right? Because you times something by 10 over 10, it's the same as not doing anything. So you're going to get 2670, right? 2670 per kilogram. That's pretty straightforward, right? Because it's going to be 10 times as much money because it's 10 times as much food. If we wanted to go ahead and multiply these out, we would get 2.67 times 1,000 equals 100x, or 2.67 times 1,000 divided by 100 equals x, right? And then we would get our 26.7 equals x, right? We would get the same thing one way or another. Right? Just write that out. For B, then, write a formula that might be programmed into the store's cash register to calculate the cost of the almond snack if you enter the number of kilograms purchased. Okay, well, that's pretty straightforward. These are just, honestly, probably the most difficult part about these questions is just, why is there, oh, crud. Hold on a second. Hold on. Tweesh shet. I'm not sure why this is not coming up quite right today with that bit at the bottom. But anyway, I'll tweak my the scene for tomorrow. For part, we'll just power through right now. That little black bar at the bottom or whatever. It's all right. Write a formula that might be programmed in for cost per kilogram. Well, that's not hard, is it? Because we just found this is going to be 2670 times, well, the cost equals 2670 times kg, I'll call that, times the kilograms, whatever, right? Turn the cost of 312 grams of the snack. Cost equals 2670 times 0.312. Because here, we're doing it times kilograms, and we know that 312 grams is 0.312 kilograms. Right? We just had to be able to convert that. So then C is going to be 26.7 times 0.312, 8.33. Don't mind that dollar sign. You know, it's about right. Predict what a graph of the equation would look like. I'm going to call it straight line with direct variation. I mean, cost for items like this, like buying something at a grocery store, is yeah, I mean, that's a good example of direct variation, right? Because of course, if you're buying 0 almonds, you're paying $0. Right? There's not a flat rate. There's no cover charge. You don't have to pay to get into the grocery store, right? You know. But hey, if you were talking about like drinks at a bar or something when there's a show going on, well then there would be a partial variation, right? Because it'd be like, you know, your $10 cover charge plus your $8 a pint or whatever nonsense it is. I don't have a pint on stream today, unfortunately. That was only for Friday, for this past Friday. And even then it wasn't pints, right? Like cans are not pints, not even close. All right, so Esther, hopefully that was useful for you. I'm just going to keep doing little bits on the current topic that you're on every day, unless, yeah, you know, if you're touching base and you're letting me know that you're still going. So I'm going to keep doing a little bit on those topics to help you through. And let me know, please, if there are any specifics that you want me to get to. But now I'm going to do a little bit for Nick Dunn. Or, geez, oh well, it doesn't really matter that I dox my students, I suppose. Because nobody online knows who they are. They're not posting. They're not saying anything. So it's just some random person, right? I'm gonna do. It's because we got two Nicks, right? We got two different Nicks, so I gotta kind of specify somehow. I guess I don't really though, because the other Nick is not doing any. He's finished his math. So let's see. I wanted to do page 82, number 20. This is the one that Nick asked for specifically. So let me go do this one. We're going to solve for x here. Let me zoom on in and let me switch over to this display. Here we go. Perfect. Perfect. This is 2101A Unit 2, I believe. That sounds right. And this is page 82 in your textbook. 82. And then this is number 20. So we're going to solve for x. Right? So, Nick, there's in your notes, you might have noticed there's a question like exactly like this in your in the notes for this unit. Right? So your notes are a really, really good resource to check. But yeah, I do welcome any and all questions, of course. Right? But this is the type of question that you will see again for sure. This type of question is almost certainly going to be on your exam. So put a pin in that one, right? File that one away in the old gray matter. But here we've got two parallel lines. We know these are parallel because let me see, is my cursor coming through? There we go, got them. Okay, so we know these lines are parallel because of this, right? You see this here? This arrow and this arrow? That indicates that this line and this line are parallel. If those are parallel, what do we know about this angle and this angle? Well, those angles have got to be equal, right? We can call those alternate exterior if we want. Again, personally, I'm not super concerned with if you get the names of them right, and I'm not super concerned with if you do it the quickest route possible, right? Because here you could also say that well we know this and this had to be equal, right? And then we know this and this had to be equal, right? Or you could say this and this are equal, and then that one and that one are equal. Either way, however you get there, as long as you get there in the end, that's what I'm concerned about. So we know then that 3x plus 10 is going to equal 6x minus 14. Right? So once we've got this, we've just got a fairly straightforward one equation, one variable. Right? So I'm just going to rearrange this as best I can. I'm going to have 24 equals 3x or 8 equals x. Easy. Solve for x. That's all you got to do. All right, so if I go on to do question 20b over here, I am going to do both these, but like I said, these are super duper really good questions. Now, B is a bit better though. B is right? We know that these two on a, over here we go. This one and this one aren't equal, are they? This one and this one are equal, or this one and this one are equal, but we're not told those two. But what do we know about these two guys? Well, because those are alternate interior, we know that the two of them added together makes 180. So we know that 9x plus 32, which is the top angle, plus 11x plus 8, those two added together, we know that has to make 180. Okay? And now, once we've got it into this form, again, we have one equation with one variable, with just x's. So we can go ahead and add these guys together. So we're going to have 20x plus 40 equals 180. Right? 9x's and 11x's is 20x, 32 and 8 is 40. Now I just go ahead, 20x equals 140, because I subtract the 40 from both sides. Then x equals 140 over 20, or x equals 7. And it just asked us to solve for x, not even define what the angle is. But if we wanted to go find the angle, say, we could do 11 times 7 plus 8, or 77 plus 8, which then equals 85, right? And we could have done the same thing over here. We could have done, say, 3 times 8 plus 10 equals 24 plus 10 equals 34, right? So we didn't have to, but we could have done that and then that afterwards. Now, Nick, I wanted to go on and do a few other questions other than the ones that you asked yourself, because this one you asked, but as we see here, once you get the first little bit, it's actually pretty straightforward, right? So it's just a matter of sort of flicking that switch and understanding that what you've got here, even though it's got algebra expressions in it, it's just the same core math as what you've been seeing all along, right? That's a phrase that I that I say a lot. A lot of times I'll mention that, oh, this is, I know it looks different and it looks more complicated, but it's actually exactly the same as what you've been doing. I say it so much that it's almost beat it to death, but the truth is that it's true. It's true most of the time. Prove that math is a parallelogram. Okay, I'm going to do this one here now on page 92. We're going to do a little bit of proof here. Now, I'm not going to do out a formal proof per se. This is page 92, and this is going to be question 1. Oh, question 10. So we're going to prove that this shape is a parallelogram. Well, how do we prove that a shape is a parallelogram? Well, a parallelogram has 2 pairs of parallel sides, right? Now we can prove that with slope, right, by getting the slopes of the lines, which is something that Betty Ann actually will have just seen in the course that she's doing, right? Nick, now you skipped some of these because of the order in which you were able to do your courses. You didn't have to do those courses, but it's still useful for you to know, right? Because unfortunately, the way these programs work is they're all cumulative, right? It's a tough word to say, cumulative. Basically, even if you get to skip past the grade 10 ones for whatever reason, you're still responsible for the material that's in it, right? In it. Still responsible for material in it. All right. So this angle here I'll call X. This angle here I'll call Y. Those are the only angles that we don't know yet, right? So how are we going to find those angles? Well, that's super easy, right? Because angle X here, X we know is going to equal 180, subtract 70, and subtract 45, right? Because all 3 angles in a triangle have to make 180 degrees. So we know that X is going to be 110 minus 45. So then X is going to be 65 degrees. Okay? So now let's get angle Y as well. So angle Y then, we can do the same thing, 180 minus 65 and minus 45. So Y is going to equal 180 minus 110, or Y is going to equal 70. Okay, so now we see that this is 70, and this one here is 65. So what does that tell us? Well, that tells us that all the angles are the same. If the angles are the same, then the sides have to be parallel, right? Because we know that parallel lines, if there's, say, a bisector that comes through it, all the angles are the same. So again, right, I'm not super concerned about you writing out the two-column proof very formally. We are teaching the formal method for doing it, but I know that can be a little bit daunting to start off with because it's sort of like a totally different language. It's a different way of writing down math and sort of conceptualizing it that might not be super intuitive. I'm more concerned for now with you being able to show me, just write it out in words so that I can follow your thought process and see why what you're saying makes sense. Okay? So for a question like this, an answer like I've written out here would get you full marks, right? It's not a two-column proof. It doesn't say step by step what we're going through, but it does explain, it does let me know that the person who wrote this understands why these angles make this shape a parallelogram. Okay? I think I know you didn't say specifically, but I can guess that any difficulty with this unit so far has probably been with the sort of the formal diction that goes into the two-column proofs, right? And how different it is from the other methods you've seen thus far. But as long as you can explain to me why these things are true, it doesn't necessarily need to follow the exact sort of formal language. Right, I'm going to go do question 11 as well. So manufacturers designing a reclining lawn chair is shown. Determine the measures of angle A, B, C, and D. Okay? So I'm going to do this question. Let me draw it out. Let me draw out roughly what we've got. So we've got a line across the middle here. Then we've got a line up like so. And then we've got one coming down here like so. Okay? So that's basically what we've got. We are told then that this angle here is 30. This is angle A over here. I'm going to do these in different colors so we can see more clearly when I'm doing them out. This is angle B. Do that one in red. This is angle C. And this is angle D here. Okay, it's a little bit tricky to see the colors there from that far out because it's kind of small. But I'm just going to go through now and well, let's find out what we can. Well, angle A, we know A equals 30 degrees because it's opposite. Right? So if you were writing out a two-column proof, say for example, you could say opposite angles are equal, and that would be your reasoning behind that one, right? So then say B, well, we know B is going to be, we know B and 30 have to add together to make 180, right? So 180 minus 30, or B equals 150. And for that, you could say straight lines are 180 degrees. You could say that as a reasoning there, right? And I would understand what you meant, that the straight line from here to here has to be 180, so that B has to be the 150, which is what's left over there, right? Just has to be. Okay. So now, well, how are we going to find, oh, right, there was one other, I didn't actually have enough information here to find these ones, so this is going to be a 115 here. Right? Well, now I'm going to go ahead and find D next, because we actually can find D, but we can't find C very easily yet. But D is going to be 180 minus 115, or D then is going to equal 65. And again, straight lines are 180 degrees. Then we know C. C is going to be 180 minus 30 minus 65, which is 180 minus 95, which is 85 degrees. And here we know triangles are interior angles in a triangle add to 180 degrees. Okay? So that's kind of what I would be looking for, right? So when you're doing a proof like that, down through here we've got the measurements, and down through here we've got a reason for them. Excuse me. So I think that is a reasonable look at these topics that I've meant to get to today. Hopefully, people found those useful. Um, Switch on back over to my intro screen. So yeah, I've covered these three and a little bit about if the planet Hoth would be good for social distancing or not, which I think it probably would be, although getting there might be tough. Though in Star Wars, I mean, you can just hop in your X-wing, right? You can just hop in your X-wing on your own and then just like take off there on by itself, right? Because an X-wing as a fighter has shields and also has hyperdrive, whereas a Tie fighter does not. A Tie fighter has no shields, right? They just they're just sticking those Imperial stormtroopers out, sending them to their deaths. Not even putting a shield on there. You know, it's cheaper to clone a new stormtrooper than it is to build a shield system for a Tie fighter. You know, that's actually true, right? I mean, boy, stormtroopers need to unionize. Is kind of what I'm saying. This is actually true. This is legitimately true Star Wars fact. You can look it up. I've played enough X-Wing versus TIE Fighter. Oh, I'm off a bit, aren't I? Have I been off all stream? Have I had that bit in the corner the whole time? Wow. Boy, shouldn't have drawn attention to it. Maybe no one would have noticed if I didn't draw attention to it, huh? But, that's just not what my stream's about. I'm just kind of here to ramble and draw attention to all my own mistakes. Right? But yeah, the point is you need TIE Advance, because TIE Advance, they have 4 lasers instead of 2, right? Which is important because they got 1 on each point of the wingtip, and they've got shields, right? It's really important. The TIE Bomber, I believe, has shields as well, but the TIE Fighters don't, and I don't really understand how the Galactic Empires can be so careless with their human resources as to not even install a shield system. I'd say stormtroopers really need to fight for their right to, I don't know, survive a single hit from an X-wing. Doesn't really roll off the tongue, does it? Anyway, it's enough. It's enough May the 4th. May the 4th banter for you today. Hope that was useful. And yeah, stay safe out there. We're all in it together. Let's get through week 6. Let's get through week 6 of distance teaching. And then we got, some more courses down. It's great stuff, right? Thanks for hanging out, and I'll see you again tomorrow.